Today to interrupt me. Uh, Good morning, everyone. Hello, everyone online, and those lucky people in Florence who found the opportunity to go to visit this beautiful city. My name is Andrejs. Yeah, I'm presenting my research as a PhD student from Charles University, Prague, where I'm doing my PhD with Dr. Martin Bilek. But also we have one more co-author, Dr. Michael Gorskis, who is located same as myself in Latvia, in Riga Technical University, and I'm doing my lectures in Daugavpils University. So as I told, I'm located in Latvia. It's a small country in Eastern Europe, but we are in European Union. And then the population is Latvia is not so big one, and we have almost 2,000 2,000 student people, school pupils. Sorry. So it's my point of view. It's a good base for research regarding the chemical education in the secondary schools. I'm also very interested in information and communication technologies using education process as Nikolai, but I'm feeling a little bit afraid because I haven't done the research so good and deep as the previous speaker. But I will present our main problem. We want to go inside and the solutions that we try to provide to our educational system. So last 7 years, so we saw the negative downtrend about the students' communication, student competence regarding the calculation tasks in chemistry in class 10. So it's right after class 8 and 9 when chemistry education starts and starts in Latvian education system. Latvian education system is switched already to the competence-based learning model, starting from this academic year. But as you see, the last year's results, we almost never saw the yellow line higher or more to the right than the violet one. So the trend is quite negative. Also, as I mentioned, the information and communication technology based learning process could help us to improve some skills in students to make the knowledge higher. The hybrid is based mostly on my generation who's familiar with technologies, and the next generation is already like very common with technologies. And of course, the last year's COVID situation increased this trend in a lot of countries. Also, it's been done in Latvia. So here we try to understand if the e-learning systems came so popular, but do they make sense? Are they so effective? So can they make the effect on students and their in our situation calculation task solving skills? So for the research, we selected the platform called Uzdom.lv here in Latvia, and why it's so. So we can see that the category rank is number 2 in Latvia. First place is taking our national learning management system, and the content-based learning system is the second one is particular portal. During the COVID, the user base grew up twice. So at the moment, we have almost all students registered. I mean, school students registered in platform. Also, a lot of teachers and their parents. Of course, parents we need mostly because of GDPR, and we give them a chance to follow the students' results. So why this platform, and what is the main advantage for the particular parameter for particular topic? So if we speak about calculation tasks, of course, it's about numbers. And if we go offline evaluating or offline training, we need to check it manually. The results have to be checked manually, and the conditions could be done. Of course, we can print out a lot of papers, uh, but it could not be done so comfortable way. So here we can see an example where when we are asked to calculate the substance in moles from the grams of water, and the conditions could be changed by randomly selecting the interval. Here in this particular example, we take number from 1 to 100 with precision 2, so 2 digits after comma, and we have completely different condition for the next attempt. So it means that each student can go same competence tasks unlimited, almost unlimited times, and after the unsuccessful attempt, he will get the solution steps. So advises how he have to go with the particular task and try again with different conditions. Yeah. So we give this chance, and the platform gives us an opportunity to implement as a trainer that could be adjusted by student, by teacher. And for numbers, we have intervals, and for the text answer, we have the values we can write inside before. So content is could be created same way as we created for paper, but much more variation, almost limited for the uh, number for the numbers. Here is a very simple example. Of course, the if we ask about the simple compound molar weight, it could not be done unlimited the times. Yeah, but we can see here the difference. If we run 3 times same task, we will be asked about the molar weight of 3 different compounds. Yeah, sorry, maybe the pictures are not corrected. It's more just for example. Um, what is the approach or the goal of this approach? So if we come to the memory retention test and repetition uh, repetition goals, so we try to get memorize something. So here we have the opportunity for the retention by same competence, but the different conditions to not make the memorizing fact, but memorizing competence. Yeah, so take it as a habit or something like this. And if we speak about the scenarios, how this system is used, or how it also how it been used during the research, we have two or yeah, almost 2 scenarios. So first one is when teacher is initiator, so teacher configuring the test works from the ready content. You can analyze make a diagnostic for students, analyze the results because it will be received automatically if numbers are correct or not, and create the individual plan for the student. Student could run this individual plan, and student is available to run it all the tasks included in the plan in unlimited times and do mistakes, follow the solution steps, and go to the correct result to finish the individual plan and implement, make a self-evaluation also. And also, uh, this system gives an opportunity for student to go without teacher, to go full self-learning process, run individual plan generated by system, and follow and reach the same competence as it could be done with the teacher help. At least the idea is like this. So how research should be configured and implemented? Thanks to the big user base, we've been able to select 5 schools for experiment. I will give the conditions how, and the proposal for the research been sent, thanks them for the agreement. So totally 250 students participated in experiment with their teachers, of course, managed by their teachers. So we selected similar classes by some criteria and made the diagnostics for calculation competences, separated these 250 students into the 5 groups, 4 experimental group and 1 control group, and made the follow-up tests and final tests and for to have it result was our strategy successful or not. The experimental group also made the self-evaluate. As about the group selected, so 5 schools gave us average score of their students who can participate in experiment, and we selected the school number 3 as a control group with the average score rate as a 51, and other groups been selected as experimental groups with the lower and higher result a little bit, but the delta been not more than 7% from the lowest and the highest. This is why we made the pre-test, called this diagnostic test for the groups, and the average result being quite similar for each group, and delta being almost 1.5%. So the groups being counted as equal starting knowledge, maybe different motivation that could be done with one more research which we started right now. So this group's been ready to run the pedagogical experiment where we created tasks by 7 competences that is included in the 2nd semester of class 8 Latvian education's curriculum. So if we go to experimental groups, they had opportunity to run each competence task unlimited times, and they have immediate check and feedback after the task is done, and the limited approach to the e-learning platform being provided. The control group run the same tasks without the variations and trained only on paper without e-learning system approach, without possibility to go same tasks in e-learning systems, and the result being checked by teachers, so it took time, so there is no immediate feedback and result. So the question bank created for control group and the experimental group from the same basis. So control group got 22 tasks with same conditions almost, but for the experimental group, we created the variations with different compounds, different reactions, put the interval of numbers, and in the result, we got like more than 1,700 different tasks, so tasks with different conditions that could be trained for the experimental group. As a result, the follow-up tests been done after each month of education, so it's whole 2nd semester, and the final test been done in the May. We are talking about the last academic year. So if we can see here that the control group result grow is the lowest, but it's close to the experimental group 1, close to other groups, but the group 3 made the highest grow of the result. It could be explained also by the motivation of the 3rd group, because I know this group more individually, but also we can see that it's not the same trend everywhere. For example, in the group number 1, the second follow-up test being done not so good as the first and the third one. And also we can see that the third group done the last test same way as with approximately same result as a control group. And all the tests been done on paper, like manually and manually checked to have the same conditions. Only training being done by e-learning system. If we speak about the final diagnostic, so here we made the diagnostic with the final test been made by checking each competence separately, and some kind of trends we can see, like for two groups, molar weight and mass calculation being done more successfully, and the third one and the sixth competence is units of measurement using, and the volume substance calculation been done for three groups more successfully when for control group. And again, we can see that group number 4 is been showed the results same as a control group, right? Really close one. And from 1 to 3 groups, they showed the higher result. And if we compared also the pre-test, the post-test, so the first and the final diagnostics, so and saw some kind of trend for the group number 1, 2, and 3, and also so the same progress, almost same for the group number 1, group number 4, and the control group. That also is giving us an information about the probably the ICT could not solve all the tasks, all the problems. So the experimental groups, we made not so deep maybe, but self-evaluation, and we've been interested about their own feeling after the experiment. Do they feel that they learned all the necessary competences on, and also do they feel confident with calculation tasks after training on e-platform? As you see, mostly we got the positive self-evaluation, self-rating. So the 5 being like fully yes, and the 1 totally no. And the last question being about the e-learning system usage for self-learning in the future. So I feel that e-learning system could be used for self-learning, and the teacher role is not so important. And here also we saw the positive trend for that, but not for everybody. So the numbers here mean number of students. What we got in the end, the experimental group, the lowest initial rate showed the lowest progress during the experiment. So there is no motivation factor of e-learning system, wasn't a motivation factor for them. And experimental groups totally demonstrated higher overall results compared to the control group, almost in all tests, with the few exceptions. But the final test showed that experimental group from 1 to 3, first, second, third group, but not fourth one, that showed lower than results lower that control group. Sorry, some kind of mistake in this conclusion. And experimental group number 3, they showed the highest result, and the as I told, the motivation for this group being the highest one. And it's about the the survey, it could the self-evaluation survey, it could indicate that the majority of the experimental group feel they very confident with the calculation task after the experiment, and they feel that e-learning system could help them to, to organize the self-learning process. But the common knowledge or feel is that is that okay, the e-learning system could be the good additional tool for the learning, but no, hopefully nobody will change this teacher main role in the education process. Maybe I'm being so too fast, but this is all. Thanks for your attention. Paldies par uzmanību, and I'll be